Hello, for those of you that made it. So welcome to your third video lesson for today. Now, remember, this is just me going over homework. So if you feel like you've got it, you might not need to watch this one. And if you feel like halfway through you've got it, then you can stop watching it, maybe try the problems, and then check your answers later. So the first page on sheet 8 is more answering questions based off of the theory. So the first thing I ask you to do is fill out the shell and orbital filling pattern on the periodic table. Ignore that. That's from a while ago. So I'm going to add the colors because I love colors. Remember that the main columns, the tall columns, fill in row number. So I'm just going to go row 1, 2, 3, 4, 5, 6, 7. Anything on this side is going to be in the S flight path. And then the electrons are just going to fill in order. So 2s1, then this would be 2s2. 3s1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So that is the S block. The P block and helium is also just going to follow the row numbers. So this is row 2, 3, 4, 5, 6, 7. And these are all going to be P's. So 3P, 2P, and they're going to fill in order. So 2P, 1, 2, 3, 4, 5, 6. 3P1, 3P2, 3P3, 4, 5, 6. So these are all just going to fill normally. 4P1, 2, 3, 4, 5, 6. All the way down to the bottom. 6P1, 2, then the d orbitals, and this is a typo. That should be up on this first line. So the first line is going to go 3D1 through 3D10, and then these are all degenerate. So it's in row 5, but they're going to be a shell back. Fourth shell. Row 6 is going to be the 5th D shell. And then row 7 is going to be the 6th D shell. And then those very bottom ones, remember, they're 2 back, and they get pulled out of right here. So instead of being the 6th shell, they're going to be the 4th. And the F's go up to 14. And instead of being the 7th shell, they're going to be the 5th. And the F's go up to 14. So that's all this first one is getting at, is getting you used to reading the tables. If I point to an element on the periodic table, by the time we get to the test, you should be able to do the electron configuration just from this kind of filling pattern. Okay, so question 2, describe the difference between electron filling in the main block, which is my red and my blue, and then electron filling for the transition metals. All right, well, the answer is on my table. So my main block elements are always filling the largest shell or the highest energy level shell. They're always putting that final electron in the highest or the valence shell. The green and the purple, those transition metals, the green ones, so I'm just going to put that, are a little bit different. So when we get to those greens, we have to remember to count back. They're not putting their electron in the highest energy level shell. They are putting the final electron in a degenerate shell or a lower shell, because that's the most energetically favorable place to put it. All right, question 3. Describe the difference between electron shells and orbitals. Now, anytime I have a question that says describe the difference, I'm going to almost immediately divide my paper in half so I can talk about both. Now, if I was you guys and I hadn't been working with this vocabulary for as long as I have, I would then pull back out my notes. If I can find the front. All right. So, electron shell is the energy level. Particularly, we're usually concerned about the highest energy level, and the way we draw electron shells is with the rings, like the Bohr model. And what that energy level really represents is how far away an electron is from a nucleus. So, for example, shell 3 would be a nucleus with 3 rings. So a shell is an energy level which is distance. An orbital is, on the sheet, a shape or a flight path. So it is the shape that an electron flies in. I did not spell flies right. There we go. That looks more right. Maybe not. I'm not sure. But it is the flight path of an electron. So, for example, if you are in orbital P, you are flying around in a dumbbell shape. You are somewhere within that orbital. So a shell is how far away you are from the nucleus. It represents your energy level. An orbital is your flight path. All right. And then question 4. So why do transition metals fill their second to last or third to last orbital instead of their outermost orbital? Well, that comes back to our last page of notes that we took, which is our Aufbau principle. Electrons will sit in the lowest energy level possible. So if it is possible to fill a degenerate orbital, they're going to use the degenerate orbital. So this is just getting at the theory. Do you understand the basic vocabulary? Electrons are going in the lowest spot possible. The two components of the address that you need to know: a shell is what ring you are in, how far away you are from the nucleus. An orbital is what shape you are flying in. Main block is easy. Their last electron always goes in their highest energy level, which is also your row number. And then transition metals fill a lower shell. These bottom two rows fill 2 shells deep. All right. Now, the actual orbital notation. Now, orbital notation, remember, is the longhand. So the arrows and the lines and everything like that. That's why you have a lot of room here. So the first one we're going to do is write an orbital notation for chlorine. So chlorine is element 17, so I need to place 17 electrons. I'm going to start in energy level 1. 1s, and I have 2 electrons there, 1s2. Energy level 2, 2s2, p6. Energy level 3, 3s2, 3p. Chlorine is in this energy level, so I have to count. 3p, 1, 2, 3, 4, 5. All right. S shapes get 1 orbital, P shapes get 3, 1, 3. 2 electrons, 6 electrons, and then 5. So 1, 2, 3, 4, 5, and I'm going to have 1 unpaired spinning by itself. All right, titanium is somewhere on here. Did I give me my number? Did not tell me the number. Titanium. I think it's in the middle. Oh, right here. Titanium, element 22. So I need to place 22 electrons. So I'm going to start at the top. 1s2, 2s2, 2p6, 3s2, 3p6. Now, titanium is in the 4th row, but it's in what? Acting funny row. So 4th row, I'm going to go through the S's. So 4s2. Then I'm going to jump down 3d, and then it's 2n. 4s2, 3d2. All right. S's get 1. P's have 3 shapes. D's have 5. And now I can fill. All right. One, two. All right, so that is the orbital diagram, which is the long way. Gets a little shorter as the page goes on. And again, if at any point you're going, I got this, stop the video. That's all right. All right. 6, write the electron configuration, the whole configuration for europium, which is down here. It's element 63. So I've got to get through the F block. Now, I'm going to walk through it while I'm on the screen. So, row 1, 1s2. Row 2, 2s2, p6. Energy level 3, 3s2, p6. Energy level 4 is where the funny stuff starts. 4s2, 3d10, 4p6. All right, energy level 5. 5s2, 4d10, 4p6. Ah, 5p6. Bad teacher. 5p6. All right, and energy level 6. 6s2, now jump down. I'm going to write that before I forget. 6s2, and then 4f, 1, 2, 3, 4, 5, 6, 4f6. Right? 1, 2, 3, 4, 5, 6. Yep, 4f6. So that is the electron configuration for europium. And I don't have to do the arrows because it didn't say orbital diagram. All right, polonium. I picked big ones. Where is it? Oh, it's not horrible. All right, polonium is right here. It is in row 6, so I have to get all the way up to 84 electrons. Now, row 1, 1s2. Energy level 2, 2s2, 2p6. 3s2, 3p6. 4s2, 3d10, 4p6. Oh. Where's that? Okay, row 4. 4s2, 3d10, and then 4p6. All right, row 5. 5s2, 4d10, 5p6. Row 6, which is where polonium is. So now I got to start figuring it out. Yeah. 6s2, jump down, 4f14, jump up, 5d10, that's probably the most common one to forget. 6s, 1, 2, 3, 4. 6s4. So that is the electron configuration for polonium, and it does not get much longer than that. And I put the easiest one last. Carbon. So I need to fill 6 electrons. 1 s2, 2 s2, 2 p2. Easy. All right. Now I'm going to let you use the noble gas shortcut. So this is the noble gas shortcut for the ones we've already done. So europium, now this one is funny. You got to really have a visual of where it's coming from. It's from row 6. So find the noble gas for row 5, which is xenon. And then fill row 6. 6s2. 4f, 1, 2, 3, 4, 5, 6. That's the noble gas shortcut. Polonium, bad example. Also in row 6, so the noble gas is still xenon. Then it's all the way over here though, so it's 6s2 all the way through, 4f14, 5d10. I'm gonna write that. What was that? 6s2, 4f14, 5d10, then up to 6p1, 2, 3, 4, 6p4. Which actually, I just caught that mistake up here. This should be 6p4. Yes, there we go. So make that correction. I hope you caught me earlier when I did that. Sometimes I do. And then carbon is in row 2. So find the noble gas from row 1, helium. And then go. 2s2, 2p2. So that's the noble gas shortcut. Find the noble gas from the previous row and then list the electron configuration for the row that the element is in. Now, these are my favorite. This should take you about half a second. Which element has the electron configuration? All you need to know is the outermost one, the last one. Energy level 3, P shape, so I'm in the blue and I need to count by 3. 1, 2, 3. That's phosphorus. Done. Ready, go. Now, this one, this is 3D1. So remember, the D's are 1 back. So it's row 4, D1. This is scandium. All right. That is sheet 8. Hopefully I didn't make any mistakes while I was walking through it. If you still have time left in class, go ahead and do sheet 9, but we will practice this more later when I return.